Hey guys, so we've been working on graphing secant, cosecant, and cotangent graphs with less emphasis on cotangent, but I figured I'd throw it into the notes anyway. And one of the things that we are going to work on today is shifting and transforming these graphs. So for instance, if I see an equation like y equals 2 secant of x plus pi over 3, the first thing I'm going to do is think of which reciprocal function goes with secant. And so in my head, I know that secant is 1 over cosine. So I'm sort of thinking about cosine right now in my head. I know the period of cosine is 2 pi, or 2 pi over b. And in this case, since b is 1, my period is just going to be 2 pi. The amplitude of my cosine curve would be 2 because of this 2 out in front. And this has been shifted pi over 3 to the left. So with this in mind, I'm going to graph my cosine curve as a dotted line, and I'm going to do it first sort of ignoring the idea that it's a secant curve. So let's see, I want to graph 2 pi, so I'm going to count out. I like to go 8 squares for 2 pi. 1, 2, 3, 4, 5, 6, 7, 8. So there's my 2 pi, and that means 4 squares is pi, and pi over 2, and 3 pi over 2. And my amplitude is 2, so I'm going to go up to 2 and down to -2. And now if I was going to graph my cosine curve in, I know it starts high and it's going to come down through 0, down to its low point, back up through 0, back up to its high point. So there's my basic cosine curve. It's moved left pi over 3, so I need to move each one of these points left pi over 3. Now, if this is negative pi over 2, I know that pi over 3 is less than pi over 2. Like a third of a cup is smaller than a half of a cup. So I know I'm not quite going all the way back to pi over 2, so I'm going to shift this point back. This point gets shifted back about the same amount. This point gets shifted back. This one does also, and this one does too. So there's my shifted cosine curve. And now I know I kind of have a lot of dotted lines on here, so I'm going to switch colors. Now my secant curve we talked about the other day is going to have asymptotes wherever the cosine curve has zeros. So I'm going to get an asymptote here. And which one is the shifted curve? This guy right here. Okay. And then at the high points, my curve is going to reflect away from the x-axis, it's going to reflect up. At the low points, it's going to reflect away from the x-axis, so it reflects down. And at this high point, it's going to reflect up. And the graph approaches its asymptotes, so my arrows are going to get closer and closer to the asymptotes but never touch. So in blue, and I guess you can maybe only sort of tell that this is blue, you're getting this curve with the asymptotes for your secant curve. So the key here really is to just graph the cosine curve, do everything that you need to do with the cosine curve, and then put your asymptotes down and reflect away. Alright, for a cosecant curve, it's the same thing. So I'm going to think of a little thought bubble here. Cosecant I know is the reciprocal of sine, so I'm going to graph a sine curve. Now let's see, in this case my period has been changed by this 2. So period is 2 pi over b, so for me it's going to be 2 pi over 2, which is pi. And let's see, my amplitude is 4. Notice my amplitude is not a -4, it's +4 because the amplitude is the distance from the midline to the highest point of the curve, so it's always positive since the distance. But it has been reflected over the x-axis because of that negative. And then my graph has also been shifted up 1. Now before, up above, we saw that like if you get all of your shifts and all of your transformations in here, it's going to look really, really messy. So I'm going to start trying to do some of these in my head a little bit. For instance, if the graph is shifted up 1, I know my midline gets shifted up 1. So I'm going to dot that in really lightly. There's my midline. If my period is pi, I'm going to go out a couple of units, 1, 2, 3, 4, and put pi. And then cut that in half. There's pi over 2, there's pi over 4, and 3 pi over 4. My amplitude is 4, so above the midline I know I'm going up 1, 2, 3, 4. That puts me at 5. And 4 below the midline, 1, 2, 3, 4. That's going to put me at -3, since my midline is sitting at 1. Okay. And and it's a sine curve, so it's going to start at the midline, and normally it would go up, but since it's reflected, it's going to go down first. So my sine curve will start at the midline. Because it's reflected, it will go down, it'll come back up to its midline, go up, come back to its midline at pi. Here's my sine curve, and I realize that it's a little tricky because I did a lot of those transformations in my head, and you can only really do that after you've done enough transformations, after you've sort of graphed enough of these. Okay. Well, so now, this is a little funky, right? Because I've got this shift up. And the debate is going to be, should my asymptotes be at the midline, where it's hitting the midline, or should the asymptotes be where the sine curve is actually hitting the axis? And if you're uncertain, which, like right now, I'm thinking to myself, I don't know where my midline or where my asymptotes should go. I mean, I know that I'm going to reflect, but where are those darn asymptotes? One of the ways you can check is to see what causes there to be an error within this function. Okay? And you can do that pretty nicely with your graphing calculator. So if I grab my calculator, right now I'm debating about whether I put my asymptote at pi over 2 or whether I have to figure out where this crosses the axis, which is going to be annoying, and if I have to put an asymptote here, okay, which I don't know what that is at the moment, so I'm going to do pi over 2 first because I'm hoping that'll work out for me. Okay, I'm going to zoom in on this so you guys can see it a little bit better. Okay, so it's like, does my asymptote go there? Or does it go there? Is sort of the question I'm asking myself right now. And pi over 2 is easier, so what I'm going to do is I'm just going to type pi over 2 into this function in my calculator. So -4. Now I can't do cosecant, so I have to do 1 divided by sine. And then I'm going to do 2 times, and now I'm wondering about pi over 2. So pi divided by 2. Close that parenthesis just like it is up here, and then say +1. Error, divide by 0, quit, go 2. Okay. So that means that this pi over 2 was a problem. I couldn't plug pi over 2 in. Pi over 2 was an error. And so that tells me that my asymptote should be at pi over 2. Right? And that means my other asymptote will be at pi. And my other asymptote, which I guess I'm going to have to do in blue so you guys can see it, will be at 0 because that's the other place it hits the midline. Okay. And then from there, once I get my asymptotes in, my graph curls away from the x-axis from both the high and the low points, the mins and the maxes. Okay. So double checking that again, I want to make sure that pi is really an asymptote. I can hit secant and then the enter button to pull up, oops, did I do -41 there? I might have. -4, times 1 divided by sine. There we go, that's where I got the 41. Okay, and then I need sine of 2 times, I'm going to check pi now, +1. And I get another error, so in fact that is an asymptote. Okay, so little asterisks you might want to put on your notes here. Asymptotes occur where sine or cosine hit the midline if the graph has been shifted up or down. So it's not always where it hits the x-axis. If we have this shift up or down, then it's wherever it hits the midline. All right, and then, last but not least, I figured I'd throw a cotangent curve in there just for kicks. So the cotangent curve has a period of pi typically, but we have a b value, so now it's going to be pi over 2. And this is like an amplitude change, but you don't talk about amplitude with things that are not waves. And since this isn't like a wave that comes up and comes back down like a cosine or sine curve, we don't really call it amplitude, but it has been scaled by 3. 3 is a scalar. It is going to make it like longer and skinnier. So I go up 3 and down 3. I'm going to come out and put pi over 2 for the end of the period, and then cut it in half is pi over 4, and half again is pi over 8, and then this would be 3 pi over 8, because 1 pi over 8, 2 pi over 8, 3 pi over 8. Now, cotangent has asymptotes on its outside edges. We saw that in the last set of notes. It's where tangent equals 0 is where you get your asymptotes. And so then the x-axis is actually an asymptote also for us with cotangent. And it hits its key points at 0 in the middle of the graph. And it has a negative slope, so it's going to hit at pi over 3 is where it hit, or sorry, pi over 8 is where it hits 3. And 3 pi over 8 is where it hits negative 3. And so you could get a graph like that guy for cotangent. Now, if you didn't remember what cotangent looked like if you weren't sure whether this should be at 3 or this point should be at negative 3, here again you can use your calculator or you could do this by hand. If I type in 3, now let's see, cotangent is the reciprocal of tangent, so I have to do times 1 divided by tangent. And I type in pi over 8, I should get, hopefully, 3. Oh, and I didn't. Let's see why. I'm in radians. Oh, junk. I really wish that this wasn't on video right now. What did I do? Let's see. Well, let's see what tan of pi over 8 is. Tangent of pi divided by 8. That is a problem. Am I really in radians? I really am. Oh, whew. I forgot the 2. I forgot the period change, I think, last time. Let's see. I'll bring it back up. Yep, I forgot the 2. Oh my gosh, so much better. Okay, so I'm going to insert a 2 times there. Or 2 pi over 8 would do the same thing, right? Whew, okay, there we go. So tangent of 3 times the cotangent of 2 of pi over 8 really does give us 3 if I plug it in, and this is how you'd have to do it to see it on your calculator. And then to sit this one is really 0, I could do the same thing, but I would plug in pi over 4. And it gives me a problem. Oh, it's giving me a domain error on this one because I'm putting tangent in the bottom. And is that why it's doing it? Oh man, cotangent, why are you my foe? I hope people haven't made it this far in the video. If you guys could just stop listening right now, that would be great. No, but seriously, what did I do wrong? Let's see. Well, I have a 2 that time. Let's see what... Okay, yeah, quit there. Let's see what tan of 2 pi divided by 4 is. Is that where I'm getting the error? That's where I'm getting the error, so it doesn't like tangent of pi over 2. That makes sense because I think tangent of pi over 2 is undefined. That's where our asymptote is. Oh yeah, that makes sense. So, the unit circle, here's pi over 2. At pi over 2, I'm at the point over 1 and up 0. So one way to define tangent, so tangent sine over cosine, right? So tangent of pi is sine, which is 0, over cosine, which is 1. Oh, sorry. I went over 0 and I went up 1. So this is 1 over 0, which is undefined. There we go. Okay. So here, tangent of pi over 2 is undefined because we get sine over cosine. There we go. So then if I do 1 over tangent, and this has actually come up in class, it's 1 over 0, which technically is a really big problem because it's also undefined. Like this thing right here is undefined, 1 divided by something undefined. This is why the calculator is giving us an error. But cotangent, even though it really is the reciprocal of tangent, I think technically is defined as cosine over sine. And cosine here is 0, and sine is 1, which is equal to 0. So your calculator is going to have a little bit of trouble with this one. It's going to tell you that that's undefined, when in fact it's not. It really should be 0 on the graph, so that one should be matching up. And then same thing with 3 pi over 8, and then at pi over 2, you really should get an asymptote there. All right, well, thanks for sticking with me through the train wreck of the last 5 minutes of these notes. I'm glad I figured it out eventually. Math should make sense. Hope you guys have a good night, and I will see you tomorrow.